Welcome to Geometry 2.8, Parallel and Perpendicular Lines. We're going to review finding the slope of a line, and then we're going to apply the lesson that we learned about the relationships between two lines parallel versus perpendicular from our lab. And then finally, we will use that information and a lesson from algebra to find the slope of a line given information and write an equation of a line. So objective 2.81 is finding the slope of a line. We've had a lot of practice with this. This is a review of algebra and often taught in 7th and 8th grade math as well. Our slope of a line, M is slope, is equal to our change in y, we've also seen this as delta y, over our change in x, also seen as delta x. Where our x values are not the same, this is why in our lab we could not have two values one on top of the other, because then they would have the same x value. In this case that would be 4. We cannot have the same x value. Okay, so where the x values are not the same, otherwise we would be dividing by 0, and dividing by 0 is undefined. So our change in y, or delta y, divided by our change in x is our slope. And when we're given that in coordinates, that's going to look like taking our second y and subtracting our first y in our numerator, and then taking that second x and subtracting the first x in our denominator. So we'll work through a few practice exercises here. We're given 2 points. We'll go ahead and label the coordinates of those points. Our x-coordinate is how far over. I'm going to do that in blue. So to get to this point, I go over 1, 2, 3, my x-coordinate. And this is my, if I call this my point 2, I'm going to call point 2 my k. Okay. My point 2 is 3. My x2 is 3. And my y-coordinate, that's how far up or down. This is up, which is positive 3. That's my y2, positive 3. Then my j-coordinate, I'll have that be my y, j, my 1. Call my 1 is my j. All right, so my j-coordinate, left or right, I've gone left 1. To get there, left is negative. So x is at negative 1. Negative 1. And then I went down 2. Down is negative 2. So my y2 is negative 2. These are my points. My relationship in words is slope. I'm finding slope. My equation for slope is m equals y2 minus y1 over x2 minus x1. Then substituting my labeled values into that equation, m, which I don't know, equals y2, which is 3, minus y1, which is negative 2, over x2, which is 3, minus x1, which is negative 1. All right, so I can solve and simplify. 3 minus negative 2 will be 5. 3 minus negative 1 will be 4. If I had any simplification, I could do that. I'm going to write my final answer here. M equals 5 over 4 as a fraction. This is our one place in geometry where we definitely want to stick to fractions. All right, so we can do the same thing here. If we start trying to find the slope of this line, we actually run into a problem, which is, let's go ahead and find our coordinates. We have coordinate, we go over 2, so this is an x of 2, and up 1, so a y of 1. So if this is my, let's call this my point 2, so this is x2, y2. And this is over 2, that's 2. And down 1, 2, 3, 4, or negative 4. So I have an x1 of 2 and a y1 of negative 4. But we have a problem here. My x2 and my x1 have the same value. And remember, to find slope, x1 cannot equal x2. If they do, then this is an undefined defined slope. All right. Now, whenever we have a vertical line, by the way, the perpendicular of a vertical line would be a horizontal line with a slope of 0. So this would be the perpendicular. All right. So let's look at some points where we're not given a graph. We're just given the points. In a way, these are a little bit easier. We can just go ahead and label. Let's go ahead and call this my point 1 and this my point 2. First coordinate is x, then y, x, then y. That means that this is x1, y1, x2, y2. So you can fill those values in here. Y1 is 2, x1 is 6, y2 is negative 5, x2 is negative 3. Okay. Our relationship in words, we are finding slope. The whole point here is we're finding slope, finding the slope between 2 points. And our equation is that our slope between 2 points is equal to y2 minus y1 over x2 minus x1. Substituting these values in, m equals y2, negative 5, minus, go ahead and draw out my frame here, okay, y2 minus y1, 2, over x2, negative 3, minus x1, 6. So I'm going to simplify. Negative 5 minus 2 is negative 7. Negative 3 minus 6 is negative 9. To fully simplify, if I have a negative divided by a negative, I need to simplify that to just a positive, so my slope equals 7 over 9. All right, we're going to do one more of these for time. We'll go down to E. And we're going to do this just a little bit shorter now. We'll just call this x1, y1, x2, y2. And we've labeled them here. If you'd like to skip this step and use these labels, you can. Our relationship in words is that we're finding the slope. Our equation is m equals y2 minus y1 over x2 minus x1. Substituting that in, m equals y2, that's negative 3, minus y1, that's 2, over x2, that's 4, minus x1, also 4. Ooh, what happens here? Our x1 and our x2 have the same values. That means I'm dividing by 0. My slope is undefined. I have a vertical line. All right, and we'll do F, x1, y1, x2, y2. Now we're going to do our shorter version. We're finding the slope between 2 points. The equation for the slope between 2 points is y2 minus y1 over x2 minus x1. When we substitute, slope equals y2, which is 3, minus y1, which is also 3, over x2, which is 4, minus x1, which is negative 3. When we go to simplify this one, we get 0 over 4 minus negative 3 is 7, which is 0. We can have 0 divided by a number, it's just 0. 0 pies divided by 7 students, each student gets 0 pieces of pie. So our slope is 0. This would be a horizontal line. Okay. All right. So when we have non-vertical lines, if we have the slope-intercept form of an equation, that's our y equals mx plus b form, the coefficient of x is our slope. So if we look, and then if we have the point slope form, which I'm sorry, it's not in here. If we have the point slope form, which would be y minus y1 equals m times x minus x1, we'll go into this in more detail later, our slope would be the coefficient of the parentheses with x. So in each case, it's the coefficient of x. In this form, it's outside the parentheses. In this form, there's no parentheses, but that is our slope. So for question A, when we're asked, what is our slope? Well, what is in front of the x? This negative 3/4 is our slope. For question B, what is our slope? What is right in front of the x? This is the slope of this line. Okay, for C, go ahead and try this. What is the slope? Negative 1/3. And for D, what is the slope? 3. All right. That is the end of objective number 1, finding slope of a line both from a graph, from 2 points, or from an equation.